So in this video, we are going to discuss about dynamic behavior of MOSFET. So this dynamic response of the MOSFET transistor is a sole function of time. In order to take the charging the parasitic capacitance that are intrinsic to the devices and the extra capacitance which is introduced by the interconnecting lines. So in order to understand this nature and behavior of this intrinsic capacitance, it is essential for the designer in order to know the nature and the behavior of the intrinsic capacitance for producing the high quality digital integrated circuits. Okay. So the question they will ask is explain about the CV characteristics of MOSFET. Okay. Otherwise, they will ask what are the explain about the dynamic behavior of the MOSFET, or they can also act as electrical properties of MOSFET. Okay. C represent capacitance and V represent voltage. Okay. So this capacitance is originated from basic MOSFET structures, or first one by MOSFET basic MOS structure, and next one using channel charges. Okay, and next one using due to depletion region of reverse biased PN junction of drain and source. Okay. Here all the capacitance are non-linear and it will vary with the applied voltage, so the analysis may be a little bit tougher. Okay. So based on this, I'm going to classify the MOSFET parasitic capacitance as a gate oxide capacitance and also reduced to the junction capacitance. So the gate oxide capacitance is two type. One is gate overlap capacitance and gate parasitic capacitance. So gate overlap capacitance, I mentioned it as CGD. Okay, and next one is CGS. It is called as lumped capacitance, which is independent of the voltage. Okay, next one is gate parasitic capacitance, that I can represent as CGD. Gate to bulk and gate to drain and gate to source. Okay, so it is called as distributed capacitance it depends on the region of operation. That is based on the voltage. This is independent of voltage, and this one is dependent on voltage. And next one is junction capacitance, that is categorized into two. One is area capacitance and another one is sidewall capacitance. So the area capacitance the unit is farad per centimeter square, and it is classified into two types. One is CDB. J represent junction, so D represent drain to bulk, and CSB represents source to bulk. Okay. Next one, sidewall capacitance. The unit is farad per centimeter, and it is classified into two types. One is CSWD and CSWS. J represent junction capacitance, SW represents sidewall. It is drain to substrate sidewall capacitance, and this represents source to substrate sidewall capacitance. Okay. So first let us discuss about mass structural capacitance. Okay. So here CG, so you can see the gate is overlapped with the sources and drain. So if this is my length L, so this overlap length I can represent it as LD for both. Okay, from this one is LD and this one is also LD. Okay, so I can write CGD is equal to Cox WLD. Okay, Cox in WLD, and this CGS I can write it as Cox WLD. Okay, where Cox is nothing but epsilon naught x divided by Tox. So according to the mass structural capacitance, the total value of capacitance, that is CG. Okay, CG I can write it as CGS plus CGB plus CGD. Okay, so this is my N mass. This is nothing but G, and this is source, and this one is drain. So here I have one capacitance, that is CGS, and this one is CGD, and the capacitance from this is my bulk, right? So this is nothing but CGB. B represent bulk. Okay. So during the cutoff region, there will be no channel. Okay, if there is no channel, means CGS and CGD is 0. Okay, CGS and CGD is equal to 0. I have only capacitance between CG with respect to G and bulk. Okay, so I can write my overall capacitance CG becomes CG is equal to CGB. What is CGB? CGB is equal to Cox WL. Okay, this is during cutoff reach. Okay, right. So next at the linear region. So at the linear region, there is a channel that is present between the source and drain. Okay, there is a source and drain. Therefore, there won't be a capacitance between gate and bulk. Okay, so bulk is here. Okay, so there won't be any capacitance between gate and bulk. So it is 0. And since the channel is formed and my total voltage, my total capacitance get divided. Okay, so CGS is equal to 1 divided by 2 Cox WL, and CG drain. Okay, CG D, that is equal to 1 divided by 2 Cox WL. Okay, so the total capacitance get divided into 2. So if you add this 2, you will get Cox WL, right? So you know that at the saturation region there will be a channel present. It get pinched off, right? This region is called a pinch off region. Okay, since the channel is present, CGB becomes 0, right? And due to pinch off, there won't be a channel between this one. So CGD is equal to 0, and you have only CGS. So the CGS value is 2 by 3 times of Cox WL. Okay. So if I plot the graph between, if I plot the table, so this is the gate junction capacitance. So I can write it as CGB, CGS, and CGT. What is CG? CG is equal to addition of these three values. Okay. So at cutoff region, only gate to bulk capacitance is present. That value is Cox WL, and the rest of the value is 0. So my total capacitance CG, junction capacitance value is Cox WL. Okay. At linear region, CGS is equal to 1 divided by 2 Cox WL, and CGD is equal to 1 divided by Cox WL. So if I add these two values, I will get CG is equal to Cox WL. Okay. At saturation, you know that there won't be any channel. There will be a channel. So CGB is equal to 0, and here also CGD there won't be a channel, so it is 0. Okay, and the CGS is equal to 2 divided by 3 Cox WL. Okay, so CG is equal to 2 by 3 Cox WL. So if I plot the graph between V versus C. Okay, so instead of CG, I'm going to write CG divided by Cox WL. Okay, so what is CG divided by Cox WL at this point? Cutoff region value is 1, right? So at cutoff region, you know what is cutoff region? When VGS is less than VT, that is cutoff region. So this region is cutoff region, CR. Okay, during that time, CG is equal to Cox WL. So what is CGX by CG divided by Cox WL? That is equal to 1. So that is why during this region, it is 1, and the value of Cox is due to the value of junction capacitance is due to CGB. So this is due to CGB. So after that one, after the cutoff region, it goes to 0. So the red line represents CGB. Okay. So you know that after VT it goes to a linear or saturation region. Okay. So you can see since the VG value is greater than VT, and VG is whenever the VG is greater than VT plus VDS, it goes to a linear region. Okay, so this black represent linear region. Okay, this black line represent, and that value is nothing but so this one represent CG, C D. Okay, this is CGD. So CGD is 0 for all the cutoff region and saturation region. It is 0, and during the linear region, it is nothing but 1 by 2. This is 1 by 2. Okay, and if you see the CGS value, CGS is 0 for cutoff region, and it becomes 0.5 for linear region, and it is 2 by 3. 2 by 3 value for saturation region. Okay. So next let us discuss one problem. So they have given Tox is equal to 200 Armstrong. Okay, and active device area. Okay, which represent WL. Okay, active area means WL, width and length. Width is 1 micrometer and L is 1 micrometer. So if you multiply, you will get 10 power minus 8 centimeter square. Okay, they are asking to find the minimum and the maximum gate parasitic capacitance. So if you want to find, you want to find the value of Cox. Cox is nothing but epsilon x divided by Tox. Epsilon x is equal to 3.9 into 8.854 into 10 power minus 14 farad per centimeter, and Tx value is 200 into 10 power minus 18 centimeter. Okay. So okay, so the minimum gate parasitic capacitance. So the minimum gate parasitic capacitance is thing but 2 by 3 Cox WL. Okay, so if we see compared to these three values, this is the minimum value. Okay, minimum gate capacitance value. So I am taking 2 by 3 Cox WL. So Cox value we already know, that is 175.752. W by L value also they are given, and 2 by 3 if you substitute, you will get minimum gate parasitic capacitance as 1.17 femtofarad. Okay, the femto means 10 power minus 50. So the maximum value Cg is equal to Cox into WL. Cox value we know that, and W by L value also we know. So the answer is 1.75 femtofarad. Okay. So next let me go for the junction capacitance, that is classified into area capacitance. Okay. So it is due to depletion region, right? So one is due to mass structural. Okay, the mass structural is nothing but gate overlap. Okay, gate overlap, and channel charges represent gate parasitic. Okay, parasitic, and depletion region it comes under junction capacitance. Okay, so it is due to the depletion region. It get increased if we give the reverse bias region. Okay, so I can write XD is equal to root of 2 epsilon Si divided by Q into 1 divided by Na plus 1 divided by Nt into phi naught minus V. Okay, and we know that phi naught is equal to Kt by Q ln Na Nd divided by Na square, which is represented in terms of volt. And depletion charge. Okay, so depletion charge Qj is equal to Aq xt into Na Nd divided by Na plus Nd. So you substitute this Q value. Okay, so you have to substitute this xt value first equation in the second equation. So if you substitute, you will get this equation. Okay, so instead of xt, you substitute this value. Okay, and if you bring the Q inside this square root, it becomes Q squared. So this Q and Q will cancel out. So you will get NaNd. This NaNd and this one will cancel out. So and this NaNd and this will cancel out. So you will get 2Q. So you will get NaNd, Na plus Nd, 2Q epsilon Si into phi naught minus V. Okay, so we know that Cj is equal to dq by dV. So you have to differentiate this whole thing with respect to V. So if you so you have to differentiate this one. So you will get minus 1 divided by 2 divided by root of phi naught minus V. Okay. So this 2, if it goes inside, you will get 4. So 2 and 4 get cancelled out. So you will get 2. Okay. This minus value goes off because of modulus. So you will get the answer as so if you bring the phi naught outside, you will get phi naught square. So you will get CJV is equal to A root of Q epsilon Si divided by 2 phi naught into Na Nd divided by Na plus Nd divided by root of 1 minus V divided by phi naught. Okay. So this whole term represents Cj of 0. So Cj of 0 represents zero bias junction capacitance per unit area. Okay. So this occurs due to in the reverse bias region only. So you can see the it get reduced. Okay, so I can write this as 4 power 1 divided by m. Okay, so m is equal to 1 by 2 means it is called as abrupt p-n junction profile. If it is equal to 1 by 3 means it is called as linear gradient profile. Okay, so CSBJ. Okay, this is nothing but second one, that is CSBJ. CSBJ is equal to A into Cj of 0. Okay, since V value is constant. Okay, and CDBJ is equal to K equivalent into A Cj of 0. Okay, next the sidewall capacitance. Sidewall capacitance to sources equal to perimeter of C SWJ of 0, and C sidewall capacitance of drain J is equal to K equivalent P into Cj of 0. Okay, so A means length into width, and perimeter means that is equal to length plus W. So I can write this diffusion capacitance is equal to Cj of 0 into A plus Cj of sidewall capacitance into perimeter plus Cj of gate edge, okay, into width. Okay, so this I can write it as so this I can write as Cj of 0 into length into width, right, plus Cj of sidewall capacitance into 2L plus width. Okay, and this is due to the gate edge due to the source side. Okay, so if I want to find the value of what is K equivalent, you can solve this one. Okay, so if I want to find the value of K equivalent, so what is you can see what is the value of K equivalent. Okay, so for that one I can write Cj equivalent is equal to del Q divided by del V, that is equal to Qj V2 minus Qj of V divided by V2 minus V1, that is equal to 1 divided by V2 minus V1. This I can write it as Cj because Q is equal to Cv, so I can write Cj of V into it moves from V1 to the voltage is from V1 to V2 dV. Okay, so CJV represent this is a CJV value. So A Cj of 0 divided by 1 minus V divided by phi naught of 1 divided by m. So you substitute that value. Okay, and if you differentiate this value, okay, so if you differentiate you will get this answer. Okay, then you have to substitute the instead of V you have to substitute V2 minus V1. So if you substitute you will get this. Okay, so for abrupt p-n junction, if you substitute m is equal to 1 by 2, you will get the answer as this. Okay, so this whole term, that is we know that Cj equivalent is equal to K equivalent A Cj of 0, right? So this whole term represent the value of K equivalent. Okay, so it is a dimensionless quantity and it ranges from 0 to 1, and it is also depends on the value of V2, V1 and phi naught.